Okay, so we're gonna make sure real quick, you've already learned 7.2, we're gonna make sure we're good with 7.2 before we go on. So just watching to make sure. So if I said to you simplify, everyone looking, this is not a distribution problem. Look, there's all multiplication signs, so we can just reorder it. 5 times negative 2 is negative 10, x to the first times x to the third. When you multiply, you add, right? So it'd be negative 10x to the fourth. When you multiply, you add. So a half plus 1 would be 3 halves, everyone. So that'd be y to the 3 halves. Do I need to flip negative numbers? No, negative exponents only, so we're good. Okay, looking at this one, if I said simplify, doesn't that mean do what I'm asking you to do? So simplify, period. It's multiplication. So we would distribute. So this would be 5x cubed. And then we would have minus 10x squared. True? Okay, awesome. Then right here, if people were getting so thrown off by this, but if you could just do that problem right here, then you can do this problem right here. So let's multiply this out here. Oh, that's still not good enough. Okay, 5x to the negative 1/2 times 2x. Why don't you do 5 times 2? 10. And when you multiply, so negative 1/2 plus 1. Positive 1/2, right, everyone? And then we have 5x to the negative 1/2 times negative x to the negative 3/4. So 5 times technically negative 1 is negative 5. X to the negative 1/2 times x to the negative 3/4. So that would be this. X to the negative 1/2 plus negative 3/4. So you would get a common denominator times by 2 over 2. Negative 2/4 minus 3/4 is x to the negative 5/4. And then we could be done, or we would flip this bad boy down. So our final answer could be this, 10x to the 1/2 minus 5 over x to the positive 5/4. Right, everyone? Are we good with that? Okay. Sweet. Okay, let's just do this one. It says, simplify by factoring out x to the negative 1/2. So we are factoring out an x to the negative 1/2. We've got to write it. Now left in our first and last term here, divide by x to the negative 1/2. Divide by x to the negative 1/2. So now 4, well, careful though, is it just a 4? So we have a 4, and then when you divide the same base, you subtract your exponents, the top from the bottom. So it'd be 1/2 minus, the bottom is negative 1/2. So that'll be plus. Now that's gone. So that's 1/2 plus 1/2, which is 1. So we have x. Okay, good. And then right here, these are the exact same thing, so they divide out, and then a plus sign is still there, plus, and then 2x plus 1. True? So then we could combine like terms. So we have x to the negative 1/2 inside, 2x plus 4x. 6x is plus 1. And then what would I do with my last problem? Yep, we take the base, flip it down. So it'd be x to the positive 1/2. There's our answer, right? Did you guys all do okay with that on the homework over the weekend? Yeah? No? You want another one like that? Yeah. So simplify by factoring out x minus 4 to the negative 1/3. So we'd write out x minus 4 to the negative 1/3. Then we're going to make our parentheses. We have stuff left in our terms. So divide by x minus 4 to the negative 1/3. Divide by x minus 4 to the negative 1/3. So in my first term here, 2. When you divide, oh look, aren't they the exact same thing? So then we have a 2 and a 4x minus 3. Then don't we have a plus sign? Plus 12. And then when you divide the same base, you subtract the exponents, the top from the bottom. So 2/3 minus negative 1/3. So then it's plus, so 3/3, which is 1. So you're saying it's x minus 4 to the 1. Can't I distribute and combine like terms inside? 8x minus 6 plus 12x minus 48. Are we doing okay here?
Why can't you factor out just an x for the 4x minus 3?
Just an x for the 4x.
Like why isn't it 3x? You know there's an x to factor out.
It's 4x minus 3. Can we pull out stuff across subtraction signs?
Oh.
Does that make sense? It's connected by it. Does that make sense?
Yeah.
That's like kind of like squaring that and squaring that. Like you can't.
Only do it for the exact.
Well, because if I pull out x, what would I I do? Divide by x, and now I have negative 3 over x. Do you see how that wouldn't even make sense? It wouldn't make it better. Okay, so then right here, so then we combine like terms. So we have, let's just flip this while we're at it. So on bottom of our fraction, we have an x minus 4 to the positive 1/3. And now on top, we still have all this stuff. 8x plus 12x. Isn't that 20x's? True? Negative 6 minus 48. 48, 49, 50, 51, 52, 53, 54. So minus 54. Then I would check, actually, do either of these divide by something? So could we now let's just be done. That's good enough. All good? All right, so now we're going to 5-1. So it's going to be a lot of easy stuff. Okay, adding and subtracting polynomials. You need to understand vocabulary words. So if I said to you terms, how many terms does it have? Terms are separated by plus or minus signs. You need to know that. So in the example, in this first little piece here, if I said how many terms does this polynomial have, you would say there is 1, 2. Terms are separated by plus or minus signs. Now degree, if I said to you what degree, we give the degree by the highest degree of the polynomial. So first of all, you would make sure it's in standard form. Standard form means highest degree to lowest degree. And all like terms need to be combined. Then you can answer, it's degree 2, because that's the highest degree. 2 terms and degree 2. Are we all good with that? Okay, look at this next one. We would first need to combine like terms. 3x squared plus 4x squared. Isn't that 7x squared? So we have 7x squared minus 2. How many terms do we have? And what degree is it? 2, okay? Okay, looking at this. 4x's minus 5x's. Negative 1x. True, everyone? So how many terms is there? And degree 1. So what if I just had this? 4. How many terms is that? 1. What degree is it? Nope. 0. There's an x to the 0 there, right? This is 1. How could this one be 1 then too? Does everybody see how this is not 1? It's x to the 0, which is why it's not there. Because any base to the 0 power is 1. So 4 would be a constant, which would be degree 0, everyone. Okay, just making sure we're good with that. Okay, 3xy's minus 7xy's is how many xy's? Negative 4xy's. I always have people say something really weird right here. They go, oh, well, the 3 minus 7 is negative 4, and then the x subtract x is gone, and the y subtract y is gone. That's not how this works. The apple and the apple can be combined. The apple doesn't change. Do you get what I'm saying by that? 3 apples minus 7 apples is negative 4 apples. The apple doesn't go away. Okay, so we have negative 4xy plus 5xyz. We can't combine these. This is an apple, this is an orange. They can't be put together. Now, technically, listen to this. This is a true fact, and on an ACT you could be asked, what degree is this? First of all, this is actually, even though we can't put them together, it would still be, because of multiplication, it would still be considered degree 2 here. Multiplication, multiplication, degree 1, degree 1, degree 1. So this would still be considered degree 3. So we should write that, 5xyz plus, oh, it's minus 4xy. So we would say there is 2 terms, and it's degree 3. Okay, so also, we have to know when something is technically a polynomial versus not a quote-unquote polynomial. So polynomials are, for example, x squared plus 3x minus 2. Because it has positive exponents, and because the exponents aren't fractions, we are good. So right here, the x to the negative 2 plus 3x minus 2. Because of the negative exponent, it's not considered a polynomial. We can still have something like that, but it's not a polynomial. Now looking right here, this is not a polynomial because you can't have an x on the denominator. You can't have an x on the denominator of the fraction. Now that's different than having this. 3x minus 2 divided by 5. Well, that's just 3/5 x minus 2/5, which is a polynomial. So x can't be on bottom, but we can have fractions, just not with x. So then right here, this is not considered a polynomial because it has fractional exponents. Because technically, if we can remember to last time's lesson, that's 2 minus 5 times by the 4th root of x cubed. Radicals are not considered polynomials. So answer the question for me. How many terms, what's the degree, is it a polynomial? So you're only going to answer those questions if it is a polynomial. Is this one a polynomial? Yes, so it has 1, 2, 3, 4 terms and it's degree 3. Is this one a polynomial? No, so we're not going to answer those questions. Is this one a polynomial? Yes, because 3 and 3 divide to be x squared. Negative 9x divided by 3 is negative 3x's. 27 divided by 3 is plus 9. You guys see how that's okay? So this would be a polynomial. It has 3 terms and it's degree 2. Okay, this one's a no, right? It's x on bottom. And how about this one? Yes, it is. Is it in standard form? Degree 3 and 1 would be degree 4. Degree 3, degree 2. So we're good. There's 3 terms and it's degree 4. Okay, this stuff's so easy that taking notes is pointless. It honestly is. We know how to add things, so it's just making sure. So it says, take this polynomial, add it to this polynomial. So combine like terms. Negative 4x cubed plus 2x cubed. Negative 2x cubes. Positive 9x squareds, any other x squareds. Plus 9x squareds. Cross them out as you go. Plus x plus 6x. Plus 7x's, and then negative 3 plus 5. Plus 2. So this would be 1, 2, 3, 4 terms, and it would be degree 3. Okay, addition is super easy, guys. We don't have to distribute any negatives, so it's just super straightforward. 5w to the fourth minus 2w to the fourth is 3w to the fourth. And then negative 3w cubes plus 1w cubes is negative 2w cubes. Any w squareds? Minus 7w squared, and then we have plus a w minus 8. Are we all doing okay with this stuff? Super easy, right? So degree 4, and it has 1, 2, 3, 4, 5 terms. Okay, we get the picture with addition. People always have a hard time, though, when we see things like this. So, watching carefully. 5a squared b's plus 1a squared b's. You guys see how the apple part here? 5a squared b's plus 1a squared b's is how many a squared b's? 6a squared b's. Negative 3a b's plus 5a b's. Positive 2a b's. 2ab squareds minus 4ab squareds. Negative 2ab squareds. Now let's put it in standard form. So let's write out underneath. This would be degree 3, wouldn't it? This would be degree 3, and this would be degree 2. So either of these degree 3s can be written first. So I'm just going to go 6a squared b minus 2ab squareds, which can't be put together. And then we have plus 2ab. Yes. Highest degree to lowest degree. Good question. So then this would be 3 terms, and it would be considered a degree 3. All right, so with subtraction, we have to make sure to distribute the negatives. So this polynomial doesn't have a negative in front, so it just stays the same. 5z cubed plus 3z squared minus 3. Now watch, I'm distributing the negative and writing it right here. Don't distribute like twice. Like just take this and distribute and write what you get. So then we get plus 2z to the third minus 7z squareds plus z's minus 2, then just combine like terms. You've already distributed the negative. 5z cubes plus 2z cubes is 7z cubes. 3z squared minus 4z squared is negative 4z squareds. Plus z's, minus 3 minus 2, minus 5. Easy stuff, just making sure we distribute the negative. Do we get the picture here? Do we need another one? With subtraction. You just distribute, wouldn't you? Combine like terms. Okay, so now you might see this notation. In fact, you're going to. F plus g of x. We know from previous years that that just means take f of x and add it to g of x. So same with f minus g. F was first in this statement, f minus g, so it would be f of x minus g of x. So let's find both of those with this f of x and this g of x. So it says find f plus g of x. So we take f of x and add it to g of x. My f of x is parentheses x squared minus x. Plus, my g of x is x minus 2. With addition, we don't need to distribute anything. So we'd have x squared minus x plus x is gone, and then we have minus 2. That is f plus g of x. Then over here, it's f minus g. So we're going to take f of x and then subtract it to g of x. So f of x is x squared minus x minus all of g of x. So I would need to distribute here. None of this changed. We have x squared minus x, but now we do have minus x plus 2. So that would be x squared minus 2x's plus 2. There's f minus g of x. All right, so let's see if we can do this one quickly. What's f of x plus g of x? That one's easy. We don't need parentheses, so let's do it in our head. 3x squared plus negative 1x squared. 2x squareds, okay? And then negative x plus 5x. Plus 4x's, and then 1 minus 6. Negative 5. That one was easy. Now let's do g minus f. That one you would want to write out. So we're going to have g, which is negative x squared plus 5x minus 6. Then we're subtracting f, which was 3x squared minus x plus 1. Now look, this did not have a negative in front, so that stays the same. Negative x squared plus 5x minus 6. Now we got to take the negative and distribute. Negative 3x squared plus x minus 1. Now add straight down. Negative 1x squared minus 3x squared. Negative 4x squared. So then plus 6x, right? Minus 7. Okay, now look at this one. It says find f plus g of 1. If I said do you find f of 1, you know you would take 1 and plug it into function f, wherever there's an x. So this says take f plus g and then plug in 1. Here's f plus g, isn't it? So now all we have to do is plug in 1. So we'd have 2 times 1 squared plus 4 times 1 minus 5. So then that would be 2 times 1 times 1 plus 4 times 1 minus 5. 2 times 1 times 1. 2 plus 4 minus 5. 2 minus 1. 1. So f plus g of 1 is 1. Easy? For all of us. Okay. Okay, we're almost done here. This is what's called a profit function. In fact, we shouldn't even have to write this function down, but we should write it down. Here's why. It's very intuitive. Like, it's very realistic. In real life, how would you make money if you're a business owner? Well, it costs you money to make the product you're making, and then you turn it around and sell it for more money. So how much profit do you make? Well, this is how you get it. So the profit you make as the owner, as the business owner, would be equal to the revenue, which is how much you sell it for, minus the cost that it took you to make the product. So profit is equal to revenue minus cost. Now that makes complete sense. So it's a lot of times businesses have to take this function and figure out if it's worth their time or not to sell something. For example, I'm actually a really good baker. It's like a second talent of mine. So I'll show you some things sometime. You guys will be impressed. So people always ask me, oh my gosh, do you ever sell those cakes or cookies? And I'm always like, you guys couldn't pay me enough to make it worth my time. Because product for baking is a lot of money. And I'm not just saying that. Like, I always say that. I'm like, the cost of me buying the product is not worth it. So for example, see why it makes complete sense. If it cost me $10 to get ingredients for cookies, but then I turn around and sell them for $30, I didn't make $30. I made $20. So my profit of $20 came from the cost that I charged them, $30, and then we have to subtract off how much it cost me to buy. 30 minus 10, which was 20. So let's read an example. Okay, so it says a company sells a calculator for $12. So the company sells a calculator for $12. Now it says its revenue function is 12x. Now think about why that makes sense. The revenue that they're going to make is going to be 12x. Now x is the number of calculators, right? So if they put in if they only sell 3 calculators, they're making $36. You guys see why that function makes sense? 12x. Because we don't know how many they're going to sell. They don't know either. Then it says if the company's variable cost is $7 per calculator, so if it costs them to $7 per calculator, and then it has a fixed cost of $1,200, then the cost function would be this. So our cost function would be 7x plus $1,200. Now let's think about what this would represent, for example. Okay, so could that represent? Yeah. Perfect. That's exactly what it would represent, is rent. For example, if you want to rent something, like people are always like, you should open up your own cookie business. And I'm like, okay, well, rent at Traverse Mountain, if I wanted to go in there and get one of those little buildings, is outrageous. So you would have to pay $1,200 in rent. Then it's also going to cost you $7 to make the calculator. So then this is going to be your total cost. Do you guys see why? Because $1,000 of rent, and then you're going to also have to pay for the product. So let's see what our profit function is. How much money are we going to make in the end? So we know the function. Our profit is equal to our revenue minus how much it cost us to make the product. So our profit, P of x, is equal to our R of x is 12x minus parentheses 7x plus 1,200. Now we could leave it or we could simplify it. So I'm going to simplify it. I'm going to combine like terms. So P of x is equal to 12x minus 7x, 5x's, and I'm going to take the negative and distribute it there. So it'll be minus $1,200. Everybody see? That would be how much profit I make. So now I can use that. So let's say in this month I sell 800 calculators or 800 cookies. So profit if we sell 800 calculators. So you do 5 times 800 minus 1,200. Ready, go. How much money would I make in this month if I sold 800? Last hour and it wasn't that, so that's a little awkward. Okay, so I didn't even say that they were wrong. So I was just like, sweet, and circled it. That's why I was thinking it was more. But no, that makes sense. So 2,800. So then the business owner would have to say, is that worth my money? Well, that's quite a bit of profit, right? That's after they paid rent, right? It's quite a bit of money. Okay, awesome. So that is the end of 5.1. Before we go on to 5.2, practice some. Here are the problems that I would do, the minimum problems. So this is what's required, because there's about 10 million more than that.
So which packet are we doing?
The new packet you picked up today, little thing. So it says multiply the polynomials. Now look, once people see this, they get confused on the test for this. There's a big difference. Because of the parentheses, people get thrown off up here. Well, it's just multiplication, right, everyone? This would not be a distribution problem. This would be 2 times 3, which is 6. X times x squared is x cubed. Y squared times y is y cubed. Does everybody see? But down here, we now have addition signs. We would need to distribute. So in this case, we would do 2x times 3x squared, which would be 6x cubed. 2x times positive y is positive 2xy's. Y squared times 3x squared would be positive 3x squared y squared. Y squared times positive y is positive y cubed. Now standard form is the highest degree to lowest degree. So right here is degree 4 technically. So 3x squared y squared would be written first. A cube and a cube, same thing, so it doesn't matter which one goes first. 6x cubed plus y cubed. And then we have plus 2xy, which would be degree 2. Everybody good? Moving on. So if I said to you simplify, would I distribute this problem? No, we multiply 2 times negative 6, which is negative 12. A cubed, a squared is a to the 5th. B and b to the 4th is b to the 5th. Okay. Up here, would I distribute? No, I'm trying to get my point across here so we don't have anyone do it on the test. What would I do here? Distribute. Negative 3x minus 6. Okay, next one. So if I said multiply, we would have this times all that stuff. 3x times x squared is 3x to the 4th. 3x squared times positive 4x is positive 12x cubed. 3x squared times positive 12x is plus 36x squared, right? Yeah. Easy stuff. Okay, don't let fractions throw you off. I would watch this one. So it is distribution because of the addition sign. So this times this. Now watch. Times fraction straight across. 1 times 2 is 2. 2 times 3 is 6. Then we have an x times x, which is x squared. Then we have a y times y squared, which is y cubed. Now I've distributed there. Now take that and distribute here. We'll simplify it in a second. 1 times 6 plus 6, and you said 10, and then we have an x, and then we have a y times y, which is y squared. Then 1 times 3, 3, 2 times 4, 8. And then we have an xy. So now looking at this, we would simplify this. 1/3 x squared y cubed plus 2/5. Wait, wouldn't it be 3/5? Divide both by 2, 3/5. 3/5 xy squared plus 3/8 xy. Are we all good? Okay. Okay, simplify. Do we know how to do both of these? So I'm moving on. Distribute and double distribute. Okay, how about this? Double distribute, right? Hey, with this one. Yep, it'd be technically triple times it. Take 1 times it times it times it, combine like terms. Okay, I won't waste your time if you know how to do it. How about this? Yes, you would take x squared times it, times it, times it, right? Then we'd scribble out x squared, right, everyone? Then we take 5x times it, times it, times it. Then we would scribble that out. Take 2 times it, times it, times it, and combine like terms. Okay, what is the difference between these two problems? People get confused on the test. Would it be appropriate to take, I hope you're all watching, and just square that, square that? This is actually 16x squared plus 9. No, good. Because of the plus sign, heck no. That's called, what I call breaking the most forbidden rule. Because of the plus sign, you can't do that. You would have to write this out as 4x plus 3 times 4x plus 4x plus 3. So then when you distribute, you would get 16x squared plus 12x plus 12x, which is 24x plus 9. Do you get the same answer if you break the forbidden rule versus not? No, so don't do it. Now right, here is it breaking the forbidden rule? To square, square, square. No, because of the multiplication sign. Do you guys see the difference? Don't be the person that does that. See, look. 2 different types of problems. This, you would have to write out as 3z minus y times 3z minus y, but this one would not. You'd square, square, square. Okay, don't just square each of those. Okay, when multiplying 3 things together, this is how you should do it. Everyone listen, don't try to do it all at once. If you're ever multiplying 3 things together, multiply 2 of them together, combine like terms, and then multiply in a third. So focusing on 2 of them, you do x squared, then you have plus 3x minus 2x, which is minus 1x, then minus 6, everyone. Take that, and now once you have all like terms combined, then multiply in x squared plus 1. So now from here you would do x squared is x to the 4th. X squared times 1 is plus x squared. Now I've distributed x squared through. Negative x times x squared is negative x cubed. Negative x times positive 1 is negative x. Negative 6 times x squared is negative 6x squared. Negative 6 times positive 1 is negative 6. Combine like terms. X to the 4th minus x cubed minus 5x squared minus x minus 6. So what was the steps? Multiply 2 together, combine like terms, then multiply in the third. Okay, so they're going to write things out in function notation. F times g of x. F of x times g of x. So f times g of x just is f of x times g of x. So right here, it says take f of x times g of x. So you do parentheses, 2x plus 5 times g of x, which is x squared minus 2. And then we would distribute, right? Now watch how much easier this one is. F times g of 2. I could multiply it out, combine like terms, and then plug in 2. Or the easier way is to say, I'm going to do f of 2 times by g of 2. So f of 2. So that means plug in 2. 2 times 2 plus 5. 4 plus 5 is 9 times g of 2. So that would be 2 squared minus 2. 4 minus 2. 2. 9 times 2 is? You're fine. Have you seen me do something like that 10 times a year, so it's fine. Are we all good? Alright, we're almost done. People get thrown off with this. F of x plus h. In fact, I know people do because I saw it on the test. Last test. Especially when we have 2 x's. Now look, you wouldn't get thrown off if I said find f of 2. You'd say I take 2 and plug it in wherever there's an x. So same thing here. We take x plus h and plug it in wherever there's an x. So that would be this. X plus h squared plus 5 times x plus h. Does everyone see how anywhere there was an x, there's now an x plus h? No. Now, don't be that person, because I guarantee there's going to be at least 5 people in here that go like this. Square, square. No, you can't do that. That's x plus h times x plus h. And then we have plus 5x plus 5h. Distribute there. So now you have x squared plus xh plus xh plus 2xh's plus h squared. And we have plus 5x plus 5h. Combine like terms. Aren't they all combined? Yeah. So we're done. Alright. We're good with this one. You guys feel like you can do this one? F of x plus h minus f of x. Yeah? You sure? That's the end of the lesson. The rest of the time is yours.